Thanks for joining me here for my talk, Leveraging Cloud Abstractions to Drive Generative AI, Scalability, Efficiency, and Diverse Applications. This talk is based on my own personal views and hopefully adds value to you. In this talk, we'll go over basics of Gen AI, cloud abstractions, and how cloud abstractions fuel the Gen AI use cases. We'll also see some of the industry transformative use cases with the advent of Gen AI running on the shoulders of abstractions. So, the content of this talk is introduction to Gen AI as well as cloud abstractions by examples, and then we'll switch over to how Gen AI deployment occurs, what are the different strategies behind it, what are the different building blocks around it, how cloud abstraction benefits Gen AI, and what is the cloud adoption in general in our industry. Then we'll specifically talk about healthcare and creative content. So, introduction to Gen AI. Gen AI is generative artificial intelligence. It is a subset of deep learning that employs training on supervised, semi-supervised, or even unsupervised learnings. It differs from the determinative in the manner it operates. That is, it creates new content, is no more identifying a cat, but producing a cat out of the data it was trained on. In simple terms, Gen AI is a kind of AI that can produce output in multiple formats like text, audio, images, animations, you name it. This is a huge leap from being able to just pattern match, recommend, or identify the objects. Gen AI has emerged as a transformative technology enabling machines to create advanced context aware outputs across various domains. Some of the popular examples are DALL-E, ChatGPT, Gemini, Firefly. Next, let's AI. In our talk, it is really important to understand do they deploy. So let's start with foundational models, also known as FMs. So foundational model is an AI neural network trained on huge raw data, generally with unsupervised learning, that can be adapted to accomplish a broad range of tasks. It is a multimodal in nature, meaning it can interact from text to audio, or any other combination. GPT, clip. Next is LLM. LLMs are subset of foundational models, but they are specifically trained on a large natural language dataset. They are specifically designed for generating human language based use cases. Trained model. The trained model is the instance of model which includes learned parameters and weights. This is a crucial component. This is the model which generates new content based on different conditions. The next building block is inference code. This is typically a bridge between model and your application. This handles interaction with the trained model. It manages input, processing, encoding, decoding, and even managing the generation process. This component ensures that the user applications can effectively building block in Gen AI would be data pipelines. Those pipelines are required for pre-processing input data or formatting the output data. These pipelines ensure that the input data is correctly formatted. Next, we have to send and receive in form of web or app layer. This allows application to send request, which would be text prompts or image conditions, and receive generated outputs that would be generated text images or generated text itself in response. A simple example would be DALL-E, where you go and you prompt and then you get the output back. So DALL-E would have a API running or the UI running to process your request. Other example could be moving now to the what is cloud abstractions? Well, cloud abstractions are the mechanisms to hide the internal and complex detail of infrastructure where somehow. Cloud abstractions empower running of services, application, batch jobs, streaming, models, Consider the abstraction as a filter to put away the complex detail asides to be able to see. Now there are different type of established abstractions which have been in our industry since few years now. Those are infrastructure as a service, platform as a service, software as a service, and function as a service. The last one is the latest entry into the field of abstractions. It is also known as serverless computing. We'll talk about these all in detail, but let's talk about them in a real world analogy we can relate to it quickly. I'm pretty sure everybody has gone through the pain of buying a house or renting a room. So probably this will example. Let's start with infrastructure as a service. Infrastructure as a service is a foundational abstraction where the tier zero resources like virtual machines, storage disk, network bandwidth, etc. are provided to you. You don't have to build your own data center to get those. That's the idea behind it. Somewhere like Amazon or Google or Oracle will provide these resources to you so that you platform. EC2, Google Compute Engine, Azure. Compare this to the land you get from a builder so that you don't have to do all the work of identifying the land, going through different regulatory in order to build your home. You just out of the box. You get the land and you start building your own home on top of it. That would be example of IaaS. The next layer would be PaaS or the platform as a service, which offers a managed platform for deploying applications without the need to manage the underlying infrastructure. You don't need to set up your own subnet or routing or firewalls if you operate on PaaS. Example would be Heroku. Let's say that you're not building homes. You don't just want the land, but you also want a home. And you're thinking to probably use your expertise in up leveling the rooms, right? But there could be times where you don't have to build the room. You can customize your room, but you're not interested in building your room or building a house or getting a land. So that is something which is known as SaaS, software as a service. Shopify, HubSpot are common examples of it. SaaS provides capabilities uh, to companies and developers so that they can focus on their product and they can build their product on a manage. You might have heard about function as a service, or as I mentioned, serverless computing. This is the latest entry in abstractions where you just get the room, rent a room, and so it's basically is basically serverless computing where you run your full application. You can execute your functionality and run that functionality on a existing server. For example, Google Cloud Functions or Amazon Lambda. Example could be trigger based counter, which when there is a okay. Now you have seen some narrative about cloud abstractions and what are those. Let's move on to the so what is Gen AI deployment story? Like any other distributed system, Gen AI system is a combination of different components uh, in order to in order to ensure the use case is being served. When you go to ChatGPT, for example, when you enter any text prompt, it doesn't give you the answer by itself. It actually has a lot of revolving pieces that is needed there to empower that. So some of the building blocks we've talked about it would be models, inference code, data pipelines, web services, and there are few behind the scene which would be monitoring and alerting. Some of the infrastructure pieces like load balancer, gateways, auto scaling groups, some of the integration services, CI/CD, and some of the regulatory and security gates. So if you closely see there are numerous components behind Gen AI, and we need to deploy that. Let's see how those are being various ways or strategies to deploy these components we talked about in previous slide in order to have an end-to-end GenAI capable system. There are three major deployment strategies. The first would be in-house or private deployment. Second would be hybrid deployment. The third or the one is SaaS deployment. So the in-house deployment is basically gives you end-to-end control, but it also involves managing everything on your own. And different organizations could choose different ways of deploying this, depending upon their requirement, regulatory requirement, data privacy requirement, and their resources. But a common theme which we will try to extract from all three would be that the cloud-based deployments are a common theme across the industries. So in-house deployments basically means that having the foundational models, the LLMs, everything in-house in your own data centers, running everything in-house, including the app, including the service layer, and that requires a lot of resources, computational resources as well as expertise. Example would be generative AI system in the autonomous driving, which few car companies have done on their own. They're using NVIDIA system for training and inference, and that's obviously, even if you go this route, house or private deployment, most of the organizations which are doing this would have some kind of orchestration tools to manage the resources and provide the right abstractions. Maybe they are using Tupperware, maybe they're using Borg or Kubernetes or just Mesos, but they have some kind of empower this. A recent example would be a healthcare provider could develop a Gen AI powered medical assistant website in house, leveraging their own FMs and LLMs to provide personal patient support. This approach allows for complete control of sensitive patient data and ensures privacy regulations. The other use case I think of is defense, where uh, there would be a stricter. Next is hybrid deployment. In hybrid deployment, organizations can choose to use third-party or openly available models, be it foundational models or pre-trained models or even pre-trained APIs, to bootstrap their applications to use them. The application code could still be in-house while some of the models may be in the cloud, hence the hybrid. Model libraries such as Garden from Google is one of the example, where you actually have the offering to choose whatever model you would like as per your resource. There are advanced offerings in this field, for example, Vertex AI or SageMaker, where you get not only the model but end-to-end platform which empowers you to get services from externals. Example would be many organizations would opt for a hybrid approach using pre-built Gen AI services like OpenAI GPT-3 to accelerate development and reduce cost. This approach allows companies to focus on their core competencies while benefiting from the. So this hybrid deployment could be applicable to most of the use cases today where the regulatory running application in-house or managed services like Google or AWS. In a hybrid model also, the organizations will have to basically use some of the abstractions. With the flexibility, they can actually as needed. Next would be the SaaS deployment. In this deployment, the clients gets access to variety of models, variety of tools, variety of tools to tune the models, and also automated to productionalize the models. And can also be same or different cloud, so no need of running in-house anything. So that would be example of SaaS deployment. A lot of cloud vendors who are providing these abstractions, they are right now providing it with right controls, be it GDPR or any other regulatory Google AI Studio is one such example. The low or no code deployment model is the new entry in this abstraction field, where it is an extension of SaaS deployment where you just don't need to even write the code, and you by drag and drop. So you drag and drop your features, and you have the funnel. They are app builder solutions which are 100% in cloud, which gives the apps without knowing the how to write the code. Chatbots, knowledge systems, these are the common use cases for this type of now that we have seen different type of deployment strategies, let's see how cloud abstractions benefit Gen AI underneath. So in all the different ways of Gen AI deployment strategies, we have seen there is a need to manage the resources. Even if you run on Amazon or your own data center, you can't burn your resources. So the cloud abstractions provide you efficient resource. They focus on reducing waste and giving you the best ROI by leveraging, for example, by leveraging serverless computing and auto scaling capabilities. Organizations or companies can ensure that their Gen AI system can handle, spikes or varying workload. So beat any model, beat any model or deployment, there is a clear need to manage the allocation and utilization, and that cloud abstraction provides it. The next benefit of cloud abstraction to Gen AI use cases would be streamlined processes. So cloud abstractions empower the standardization of pipelines, be it CI, continuous integration, continuous deployment. They also provide with the streamline the agility, the much needed agility in order to move quickly with the rapid piece is scalability. So the cloud abstractions ensure that the scalability and the quality of user experience is always there. Cloud abstractions allow Gen AI systems to scale seamlessly, accommodating growing user bases or ensuring a consistent quality of experience. By leveraging the global and high-speed networks, organizations can deliver low latency or even a full-scale application or even a viral use case. SageMaker was used to scale a Gen AI based content recommendation system. And the scale was not less, it was millions of users and maintaining the performance and reliability. There are other numerous other benefits to the cloud abstraction which we have not discussed. For example, segregation and high availability. The no code model, for example, utilizes the abstraction underneath to empower a user to safely create an app with using drag and drop. The Gen AI Studio places the right controls to choose the safe models and mitigate the risk in doing so. So the existing and established offerings, like monitoring, auto scaling, alerting, those are the results of already established abstractions. Something that we Let's move forward with the current state option and Kubernetes. So most of the organizations deploy some piece of cloud native technologies today, and one of them. In general, cloud adoption is essential for managing and scaling Gen AI workloads. Cloud abstractions play a crucial role in your scalability. Gen AI is a transformative technology, and it is definitely inspiring industry transformations. I'm pretty sure we cannot discuss every industry here, so we will focus on creative content. Gen AI is also uh, uh, inspiring new growth opportunities and paving the way. So, healthcare transformation, let's talk about it. Healthcare is a field where the regulatory concerns would be very high due to sensitive data. But this is also one of the fields which requires innovation the most. For example, Clara, it's a Gen AI tool in healthcare. It reduces the phone interaction by 50%. That means that no longer you have to be on the call, hourly call to get some help. This increases the user experience, privacy. This has led to, new and improved outcomes, and it has also helped streamline the healthcare processes. Overall, Gen AI has a very positive transformation cloud role. The next industry which has seen the most impact after healthcare is creative content. With AI driven tools like Delhi or Adobe Firefly, the way you could create an image or audio has changed. Generation of digital artwork has improved by miles and miles. Now more and more individuals are exploring these tools, expressing their artistic uh, creativity. This has also this has also made the content creation future potential of Gen AI is very positive with cloud technologies. They both drive innovation and accessibility. There is a symbiotic relationship and cloud abstractions. It unlocks new possibilities and increases industries. We will reiterate that there is a symbiotic relationship between Gen AI and cloud abstractions. Abstractions are essential enablers for deploying, managing your Gen AI workloads. They provide necessary scalability, they ensure efficiency, they support diverse applications, streamlining the processes. The future of Gen AI is closely tied to continued evaluation. With that, thank you.